Okay, let's start. How are you? Thank you for coming to my session. I know that there are a lot of good sessions today, and that is difficult to pick one. So thank you so much for being here. My name is Alba Rivas. I am a developer advocate for Salesforce. And here you have my contact details. If you have questions later, you can write me on Twitter, you can write me on my email, and of course you can find me here right after the session and ask any questions that you want. So today I'm going to talk about Salesforce Functions. Any of you have played a little bit already with Salesforce Functions? One person? Two people? Okay. There's some people here who've played already with functions. This is going to be an introductory session, but if you want more advanced content or if you have more advanced questions later, we can talk about it after the session, okay? So, of course, I have to include the forward-looking statement slide, which just means that Salesforce is a publicly traded company, and you should make purchasing decisions based on the functionality that is generally available. But luckily, functions are generally available today. So, let's start by responding this question. What is a function? A function is not something that Salesforce has made up. It's a concept in computer science that other vendors have adopted to. And really a function is a single-purpose, short-lived executable that you invoke on demand. This is something that starts, runs, and finishes, normally to perform a complex calculation, right? So it's not a long-running process. Functions are serverless, which means that you, as a developer, don't have to worry about the underlying infrastructure in which functions are running. And functions are also elastic, which means that they are going to use more or less resources as needed, depending on the demand. So there are several vendors who have implemented function. The first one was AWS, with Lambda functions in 2014. Then we have also Google Cloud Platform, Azure, and this year, last year in 2021, Salesforce made their own unique implementation of functions, which are called Salesforce Functions. They are GA from October last year. So what are Salesforce Functions? Of course, they match the definition of a generic function. They are serverless and elastic. They have more compute power than the Salesforce core platform because they have more CPU, more memory, more heap size, etc. And they allow you to parallelize processes. And also, something very special about Salesforce Functions in regards to the other function solutions is that they stay on platform. They run within the Salesforce trust boundaries. Under the hood, really, they are using a different infrastructure, a new infrastructure that is built with Kubernetes. But the communication between the Salesforce core platform and the new infrastructure have been set up in a way that is completely safe for our customers. So you don't have to take care of securing all your callouts to external function system. Also, the developer experience is the same one than you have with regular Apex or Lightning Web Components development. We wanted to do it the same way so that if you are a Salesforce developer and you are used to our developer experience, you can rapidly get up to speed with functions. Concretely, in Salesforce Functions, we support 2 languages as of today, GA. One is Java and the other one is JavaScript. But there is a pilot for Python that we presented at Dreamforce this year, and there are other languages that will be adopted in the future. So which use cases can you implement with functions? So I like to summarize this in 3 groups of use cases. First of all, Remember that I told you that you have like more CPU capacity, more memory, and more heap size. So any processes that you have running in Salesforce written in Apex, with which you are reaching Apex governor limits, are good candidates to be moved to functions, because they are going to run in this new infrastructure that it's scalable, that has elastic scale implemented, and is going to be like much more powerful, right? Then there is a second bucket of use cases that you can implement in functions, which are, I have already implemented a solution outside Salesforce. I'm using AWS because I needed more compute power and I was reaching the limits. And I want to make use of this Salesforce Functions trust feature. And I want to be able to access my Salesforce data seamlessly from the function. So that's a good option to move as well to Salesforce Functions, because you can move that code, that business logic into the platform, and don't let your data go out from the Salesforce trust boundaries, and also take advantage of the improved same developer experience. And finally, of course, from Salesforce Functions, you can use third-party libraries from NPM, from Maven, so that's another use case in which you will want to use Salesforce Functions. Great, so that's what is a function, but how is this infrastructure? What's under functions? So in Salesforce, we are like trying to give a lot of importance to open source technologies, and we've turned towards open source since some years ago. So we've implemented everything with open source technologies. So first of all, we are using Kubernetes in that new infrastructure. Kubernetes is an open source container orchestration engine that allows you to run, deploy, and scale containerized applications over any cloud. Okay. Then we have build packs. We are using build packs. Build packs is another open source technology that allows you to convert your application code that's written in any language, in our case Java or JavaScript, to an image that you can run on Kubernetes. And finally, we are also using cloudevents.io. This is not a technology, it's more a specification, a standard that defines how events should be described, so that different interfaces or systems are able to use those events. So this is basically the infrastructure that we use. Okay, so I've talked about, I show you a lot of slides, but how does a function look like? And for that, of course, we are going to take a look at some code. There is a sample app called Functions Recipes that has some examples implemented for functions both in Java and JavaScript. So I recommend you to go there and take a look. I'm going to pick one of those functions. This is Functions Recipes. I've cloned the repo already on my machine. And you can see that there is a Force app folder in which I have all the code that relates to Salesforce Core. This is Apex and Lightning Web Components and all the metadata that is part of this application. And then there is a functions folder. Here is where you are going to find the different functions implemented both in Java and JavaScript. So I'm going to pick the first one. The first one is called Process Large Data. And this is a use case in which we have a huge JSON file that we need to read. This JSON file contains information of schools all over the world. And for each school, we have its latitude and its longitude. So what the function needs to do is to read this data, and according to some coordinates that are passed in, that are received by the function, decide or find which are the schools that are closest to that location. Okay, that is what the function has to do. If you try to implement this in Apex, you are going to reach governor limits because the file is simply too big, and you are going to reach like the heap size limit, and you're going to hit other limits as well. So what we did was to implement the function, implement this as a Salesforce function. Every function in Node has this structure. So we have the definition of the function. You see here the word async, because functions by definition are asynchronous and also stateless. And the function always receives 3 parameters. The first parameter, the event parameter, contains the payload with which the function was invoked. We want to send that position so that the function can compute the closest schools. Then we have a second parameter, which is the context parameter. The context parameter allows us to go back to our Salesforce OR and work with data. We can make SQL queries, we can get some information about the user, about the OR itself, and we can also perform modifications on the database. Here I'm not using this context parameter because we are not really doing anything with Salesforce, but other functions are doing this. And finally, we have a logger parameter, which helps me log, like write on the functions debug logs when we are in production and when our function is deployed, really. So what are we doing here? So first of all, we retrieve the data from the event parameter, from which we are going to get the latitude and the longitude. And then we take a look at a variable in which all that school data is loaded. That variable is initialized here at the top of the file, parsing that JSON file, that long JSON file. And we are using a function, like a JavaScript function, that allows us to find the closest schools to my location or the location provided. And finally, we return the results. Very easy. So if we want to do the same in Java, we're going to see that the code is pretty similar. It's a bit more verbose because it's Java, you know, but it's pretty similar. What you have to do is to define a class that implements Salesforce function, and then you have to override an apply method that is going to receive, again, the event parameter and the context parameter. They mean exactly the same than in the other case, in the Node.js case. In this case, for logging, we use a regular log4j instance. Great. So this is how a function looks like. Let's continue with the presentation. So, well, we have seen how a function looks like, and I show you that context parameter, but I haven't shown any examples of how to use it really, right? And here I have some examples on the slide. And by the way, I have a clicker and I forgot it. So something that you can get from that context parameter is the information about your OR, like where, for instance, the API version in which you are running your OR, or the base URL for your OR, and some more information. You can also get information about the user who invoked the function. You can get that also from the context OR parameter. You can also execute queries. Remember that this is going to be executed in a secure context. We are going back to Salesforce and we are doing that in a completely safe environment. And of course, you can execute DML operations. Here we use an API called Data API, and you have the operations for create, update, delete, and delete records. If you want to be a bit more performant, and that's a good idea, right, always, you can use something called the unit of work. Do any of you have worked with FFLIF and Apex Enterprise Patterns? Okay, so maybe this is familiar to you. This is because the person who created FFLIF, who is Andrew Fawcett, is the creator for functions, so that you know why this pattern is here. So the unit of work is a table in which you take note of the operations that you want to perform in the database. I want to insert an account. I want to insert an account, and then I want to insert a contact. And even you can relate those objects if you need to. But you perform the operations in bulk. There is a commit unit of work method that you use to commit all those operations to the database. That way, you are going to obtain a transactional control system, mechanism, right? Because doing DML operations in this way is an all or none operation. If everything works, the transaction will work correctly, the operation will finish correctly, but if something fails, the other operations are going to be rolled back. And of course, this saves API calls, because in functions, there are limits. There are less limits, but there are limits. With your license, you pay for a number of API calls, and this way you can save API calls and make your functions more performant. Great. So I told you that the developer experience for creating and developing functions is the same one done with other kind of Salesforce code, such as Apex or Lightning Web Components or Aura. But I think it's like even a bit better. You're going to see later, because we have like the local development example much more well implemented, or at least I love it. Okay, so same developer experience. First of all, we use the Salesforce CLI. When you install the Salesforce CLI, at the moment you are going to get two different executables. You are going to get the SFDX executable and the SF executable. Why do we have two different executables? Because the SFDX is kind of legacy, is the one that we created to work with core, and the SF executable is a new one, which is part of a project called the CLI unification. In this new executable, our plan is to include all the Heroku CLI commands, all the mules of CLI commands, and all the SFDX CLI commands. As functions was a new feature, we decided to create the new commands already in this new executable. But in the future, the idea is that everything is going to live in this executable. So for now, you only use it for functions, but in the future, you will use it for everything. And I've been told that some of the commands are much more performant than with SFDX. For instance, the one that creates an org. There is a blog post about that in the developer site. Also, you use the Salesforce extensions for Visual Studio Code. You install that in your Visual Studio Code, and all the commands that you have to write to start and run a function, you are going to have shortcuts that help you to execute them without having to write or remember the whole thing, which is very handy. So let's take a look at how we can use the Salesforce CLI and the VS Code extensions to run a function locally. And this is the part that I like the most. Okay, so here I have my function. We are going to work with the Node.js one. And let's say that I want to try out my function locally, right? I don't have a functions license yet. I haven't connected this to my functions account or anything. Everything that we are going to do is local. So the first thing that we need to do is to start the function, because the function needs to be running behind the scenes so that we can invoke it. And of course, we could write the SF command, but instead of writing the command, I'm going to use a shortcut, which is this one here, start function. So now my function has started, is running on my local host, on my machine, and something that we can do is to invoke it. To invoke the function, you're going to need a payload, and you can invoke the function using this button here that the Salesforce extensions add. This is invoking the function and returning the closest schools to this location here. But something that I think is super useful and something that you cannot do with Apex is to debug them locally. So here in the function, I had a breakpoint And while my function is executing and it's being invoked locally, I'm able to debug with a regular Node.js process using the Node.js debugger that VS Code has and the extensions. So for instance, I can take a look at the event content or the data. I can use this terminal here to, sorry, the data doesn't have anything, but maybe event, to debug what my variables contain and so on. So I think this is very cool and very useful. Don't you think so? Great. Yeah. So that's like the first step. I want to create a function and I can follow an iterative process, trying like to create that function locally, debugging it, and trying to fix any errors that it may have. But how do I deploy a function, right? To deploy a function, first of all, you need to connect your Salesforce OR to a functions account. At the moment, the way in which you can obtain a functions account is talking to your technical account manager and getting a courtesy license is the only way, okay? Or your technical architect. So then you connect the Salesforce CLI to your Salesforce OR as normally. And then there is a third step, which is to connect the Salesforce CLI to your functions account. This is a bit redundant, and I think it's going to disappear at some point, okay? And once you are connected to your Salesforce OR and your Salesforce account, you need to create that infrastructure in which functions run, which are compute environments. Indeed, you can create different compute environments attached to the same org. The idea is that you divide your functions by project. Let's say that you have a function for processing large data, but you have another function to create a PDF, for instance. You don't have to deploy them to the same compute environment. You can have different compute environments by project and by Salesforce OR. If you are working with Scratch orgs, it's exactly the same. The only difference is that you attach your compute environments to your Scratchers. And this is something that you can include in your CI, because the creation of the compute environment and so on is something that you do with the Salesforce CLI. Okay? So in this case, as this process is a bit slow, I recorded a video that is not showing up. See? And I multiply the speed, so how we can see here the deployment. So first thing that you do is to log into your functions account, or as I told you, okay? This is the same step that you normally do. Then what you do is to log into your function space that is attached to your Salesforce OR. This is the step that I think is going to disappear at some point. And finally, you create the compute environment. You can create it with this command here. Compute environment is going to use the project name that you have in your SFDX project configuration file. Finally, to deploy the function, you write sfdeploy functions and the name of the OR to which you are deploying the functions. And I multiply the speed of this like by 15, something like that, okay? But this is how you deploy the function. Great. Okay. Fantastic. So this is something that I did last week. The function is already in my OR deployed. And now I want to talk to you about how to invoke those functions. Let me check the time. Okay. So the invocation architecture for functions is this one. At the moment, the only way in which you invoke functions is through Apex, but of course you can call Apex from your Lightning Web Components, from your flows, etc., etc. So let's start by explaining the asynchronous invocation, which is the most common one. You invoke the function asynchronously. The function runs. If the function needs to perform any SOQL or DML operations, those are going to execute asynchronously. Remember, the nature of functions is to be asynchronous and stateless. If you need to manage state, then you will need to have like a Postgres database or a Redis database, something like that. Of course, just function can like invoke other third-party services as external API, doing some callouts, etc., etc. And when the function finishes, it's going to return to Salesforce executing a callback that you have defined asynchronously. So the the function invocation and the callback are going to run in different transactions. A typical pattern is to, if you have to perform any DML operations, place them in the callback once you return to Salesforce. Okay? What's the other pattern? Synchronous invocation. You normally perform synchronous invocation when you're using aligning with components, something like that, to get some data that is computed with functions, because you prefer like to wait and get the results sometimes. And in that case, what happens is that the Apex invocation and the callback are going to be defined in the same method. It's not really a callback, it's just that our Apex code is going to wait for the function to finish, and it's going to continue executing the lines of code that are written after the function invocation. So in this case, that's only one transaction, right? The Apex transaction. So this is the code for the asynchronous invocation. We get a reference to the function, we invoke it, and then when the function finishes, my callback is executed. And this is the synchronous invocation, in which we execute the function. Apex is going to be waiting here until the function finishes, and then we're going to be able to return the response in a synchronous way. These functions have a callout limit, of 2 minutes, and the other one 15 minutes. Okay? Perfect. So I told you that in functions there are also limits. Okay, so when you invoke functions from Apex, you have to respect all the Apex governor limits. Indeed, there is a max payload that you can send to the function, which are 6 megabytes for synchronous invocation and 12 for asynchronous one. When functions are running, we have the timeout that I told you, and also a limit on the process memory of each invocation, which is 1 gigabyte. But something that you can do is to parallelize your process and call a function multiple times if you need it to get like more compute capacity. And when you are like calling from functions to core, there is an API limit that depends on the license that you have, an API calls limit when you do those SQL queries and those DML operations. That's why using the unit of word pattern is a good solution. And by the way, that unit of word pattern uses the composite graph API behind the scenes, so you have to respect those limits as well. Okay, so finally, we're going to invoke our function. I think I have 2 minutes left. So here I have deployed function recipes. I have some Apex code and aligning with component that's invoking my function. I created a compute environment in which my function is deployed and running. And what we are going to do is to invoke the function from this lightning web component, which is passing to the function our location, and the lightning web components, it's painting, it's supposed to do it, but the internet connection is not very good. All the schools that are closest to us, I'm going to do it again, that are closest to us, to our current location in this moment from that huge JSON file, okay? Something is not working very well, but I think it's the internet connection. So that's how you invoke a function. I mean, the code is in functions recipes, and you can take a look at it, but it's exactly this code here, okay? It's a synchronous invocation because we are doing that from a lightning web component. To finish, again, if you want a functions license, you have to contact your account executive or technical account manager. I recommend you to take a look not only at functions recipes, but also at 2 repos that the functions team have created with other real-world use cases implemented. And we have also, in the developer side, a developer center for functions, where you are going to find all the documentation, all the Trailhead modules that are related to functions, all the videos and blog posts. We have also a Trailhead module about functions that you can take a look at. And I leave you here some blogs, the latest ones in which we have published information about functions. Something that was made recently, GA, is the ability to use Heroku data sources within functions like Postgres, Redis, and Kafka. And there is a blog post about this. Also, functions were made PCI compliant. And there is another great blog post about someone who used functions to create invocation to a SOAP API that is really cool. And that's all. Thank you very much. Thank you. Do we have some time for questions? Can I extend a little bit more the talk? Yeah, okay. That one was first. Not yet, but it's on the roadmap. So you will be able to have it soon. There was a function, sorry, he was next.
Yeah, you have been talking about licenses, but not like Salesforce, which is just like a fixed price. I guess that it depends on the usage, right? And the volume.
Yeah, what they give you, so the license gives you like a set of, not functions invocations, but it's a set of minutes, a number of minutes that your functions can run. So the basic license, it's $2,000 a month. So this is something that big companies have to bear in mind. I mean, you as a solo developer, maybe it's not like the best feature that you can use because it's expensive, but if you need that compute capacity and your company can afford it, of course, it's a great idea. This is the last information I have about licenses. And they give you that, like a number of minutes that your functions can run and a number of API calls that your functions can do. Yeah. Yeah, so the question if there will be any additional value if you are able to run functions for Flow, and that is something that we are working on. So we are working on other entry points for the function invocation. We are working also in the Python pilot, and we are working also in the user mode, because at the moment when you execute SQL queries or DML operations, they execute in system mode, and that's our prioritized list of things to work on next. Yeah. Yeah, it's pilot.
Because I wondered that maybe it's Node.js in Java because the functions are within the Salesforce system. So is there any future plan that you would provide the same functions as other providers like AWS standard for public use?
Okay, no, I think that the infrastructure is going to be the same, and the connection with Salesforce is going to be the same one that we have right now, because the purpose of the functions of Salesforce function is to give a solution for Salesforce customers to run functions safely within the platform. But we are going to support more languages. We are using build packs. This is the technology that allows us to support different languages, and we have Java and JavaScript available. You can watch a demo of the Python pilot in the Dreamforce developer keynote for this year, which is on YouTube or in Salesforce Plus. As far as I know, not. But I cannot tell you for sure because I cannot play with that. Sorry, the question was if we can have control over where the compute environments are located. You had a question, right? No? Okay. Thank you. More questions here?
Is it automated, or do we always need to set up compute?
You can automate it. So the question is if you have to set up the compute environment yourself. So it's the same as when you create a scratcher. You create a scratcher yourself, but you can automate it because there is a Salesforce CLI command that you can use to create that environment. And you can use like GitHub Actions to create that automatically, deploy your code, and execute your tests, for instance.
Thank you.
Okay. Yeah. Yeah, I don't know. That's where I don't know. Okay, we're using no. Yeah, we're using AWS, but I don't know the location. Yeah, okay, exactly. It's AWS. Yeah, yeah.
For the compute infrastructure, is it meant to be by tenant someday, or is it always going to be shared? Like we all run into the same infrastructure?
Yeah, that I don't know. I don't know how it works, like those details of how it works internally. I'm not sure. I cannot answer, but I can ask for you, and if you give me your contact, I can give you a
Thank you.
response like asynchronously. And
One last question is regarding the difference between core to function and function to core. Because I have to explain it.
Mhm.
This way we have internet or internet or
no. What I meant in that limit slide, core to functions, is the limits that apply when you are invoking your functions from Apex, which are the Apex limits. Maybe I should change that to say Apex to functions. And then functions to core is when you invoke a SQL query or a DML operation from functions using that context parameter.
and how do we like invoke functions to Apex to core because we have different like there is the core Apex that we can invoke. However, how can we make it?
You cannot do it. What you would have to do in that case is in Apex, in the callback, wait for the first function execution and then invoke a second function. Always the entry point is Apex. Okay?
I've seen communications when we flow in HTTP callout loops.
Mhm.
For example, the example that you make this many for HTTP callout loops.
Uh-huh.
How can you avoid that?
Yeah, so he's asking, the question is about best practices in functions. So the best way to take a look about all that all information functions related is the developer center. In the developer center, you have listed all the blog posts. If there are blog posts about best practices, you can go there. If there are sample apps that are related to functions, you can find them there. And I can share some more information with you after the session if you want. Yeah. Yeah. Thank you.